In this video, we will be going over a few problems that should help you review for your quest, which is this Friday. In this first problem, it asks us to tell whether lines M and N are parallel or not parallel and explain why. If we are trying to determine why lines are parallel, so we're not given that we're parallel, we are given angles are marked. We know that we are dealing with a converse. We are given angles, it's a converse. So we just need to determine if the angles that we're given fit one of our four types. So, are they alternate interior angles? No, they're not both in between the two angles, or in between my two parallel lines. Are they alternate exterior? No, one is inside the line, one is outside. Are they corresponding? Are they in the same position? Up here we have one on our four angles, it's the bottom right. Down here, four angles, bottom right. So those are corresponding angles, and because we know corresponding angles are congruent, we are able to say, yes, M is parallel to M, and that is due to the corresponding angles converse. In this problem, we need to identify a pair of skew lines, perpendicular lines, parallel planes, and perpendicular planes. Skew lines are lines that do not intersect but are not in the same plane. So they look like they're going different directions. So if I picked EH for skew, I would want a line that is not parallel to it but also is not in the same plane. So one that's going a different direction but it's never going to intersect it. So I could pick DC up there at the top. To pick perpendicular lines now, I would want to pick two lines that are intersecting each other and are forming the right angle. So we can pick EH again. And this time I'm going to pick one that's intersecting it. So I'm going to say AE. To find an easy example of parallel lines, we can just pick two lines that are on the same face but are going in the same direction. So it looks like they're never going to intersect each other. So again, we can use EH, and then its parallel line is going to be AD. So we have EH, and our symbol for parallel to AD. So now we need to name a pair of parallel planes. So parallel planes never intersect. So if you're picturing this like a box, if you need kind of a visual representation, think of like a tissue box. So I could say the top face and the bottom face down here are never ever going to intersect. To name our plane, we just need three letters. So we could say plane ABC is parallel to plane EFG. For our last one, we need perpendicular planes, so these are kind of like sides of our boxes that are intersecting or touching one another. So for our perpendicular plane, I'm going to use this front face here that we can see right now, AEH, and it's perpendicular to, we'll say, this side face. So these are our two faces that we're talking about, side DCG. Alright, in this problem, it gives us that line L is parallel to N and R is our transversal. So which of the following is not necessarily true? So I know that my lines are parallel. So if I look at option A, angle 8 and angle 2, those are alternate exterior angles. If my lines are parallel, I know those have to be congruent. If I look at C and I look at angle 5 and angle 3, those are alternate interior angles. Since my lines are parallel, I know those are congruent. If I look at option B, angle 2 is congruent to angle 6. Those are corresponding angles. Those are going to be congruent. And the last one that I have is angle 7 and angle 4. Angle 7 and angle 4 don't fit one of our four types of angles, so I would not necessarily be able to say they're congruent based on what is marked. In this problem, we are trying to determine if we can say with 100% certainty that any of these lines are parallel. So I have lines M, N, and O, and I'm trying to figure out, based on the information given, are any of the lines parallel. T is my transversal. I can see I have these two angles marked here. If I look at their relationships, if these are the two lines that I'm talking about, they are outside of my two lines and on opposite sides of my transversal. So these are my alternate exterior angles. Since my angles are congruent, I can say that those lines are parallel. I'm given angles. This is the alternate exterior angles converse. And so now I can say that M is parallel to N by the alternate exterior angles converse. Alright, in this problem we have a proof. So we see we have our lines L and M, and T is our transversal. And it gave us that angle 2 is congruent to angle 1. And we are trying to prove that line L is parallel to line M. So, although we can go ahead and see right now angles 1 and 2 are alternate exterior angles, this proof that we are doing here is actually proving why the alternate exterior angles converse work. So we need to go through step by step and evaluate this. So our first statement is angle 2 is congruent to angle 1. Our number one reason is always going to be given. Next, it tells me the reason is I'm using the vertical angles theorem. So if I look in my picture, I can see that 1 and 3 are vertical angles, and the vertical angles theorem tells me all vertical angles are congruent. So I can say angle 1 is congruent to angle 3. And now this is where I said we have 3 congruent statements in a row. So we want to watch out. Angle 2 is congruent to angle 1. Angle 1 is congruent to angle 3. They both use angle 1. So if I make my third connection, angle 2 is congruent to angle 3. That is the transitive property. And now angle 2 is congruent to angle 3. We can fill in our last statement. We're trying to prove that angle L is parallel to M. And if I look at it, L is parallel to M. And my statement was angle 2 is congruent to angle 3. What type of angles are those? Those are corresponding angles. And if I'm given those angles were congruent, and I'm concluding that my lines are parallel, so since I started with angles, it is the corresponding angles converse that I used.